Weight 39 concerns atomic radius. An atomic radius is a measure of the distance from the center of the nucleus of an atom to the outermost shell of electrons. This is the same meaning for radius if we were talking about a circle, from the center to the outside. When it comes to atomic radius, the periodic table follows this general trend. Atoms that show increasing atomic radius increases as we go down a group, and it decreases as we go across a period or a row of elements. If you ever forget what the trend is, you can always look up the atomic radius of an element using table S. And any questions concerning atomic radius can always be answered by looking up these values should you ever forget this trend. So let's talk briefly about why atomic radius does follow this trend. When we talk about atomic radius, it's easy to remember electron configuration. As we go down a group, the number of valence energy levels increases by 1 as we go down a group. So for example, hydrogen with an electron configuration of 1 only occupies the first energy level. The second, lithium, occupies 2 energy levels because we have 2 digits here. Sodium occupies 3. It has 2, 8, 1, 3 digits. Potassium occupies 4. So as we go down a group, the number of shells keeps increasing. So it makes sense that the atomic radius also increases. Now let's talk about why the atomic radius decreases across a period. Well, if we go across a period, looking at period 2, notice that lithium, beryllium, boron, carbon, nitrogen, all of these have 2 energy shells because they only have 2 digits present in their electron configuration. But why does the atomic radius decrease? Well, look at the nuclear charge of each of these elements. Remember, nuclear charge is a measure of how many protons that are present inside the nucleus. Neutrons don't contribute any charge, so the only positive element in the nucleus are contributed by the protons. Lithium has 3 protons, beryllium has 4 protons, 5 for boron, 6 for carbon, and 7 for nitrogen. Now, why is the atomic radius decreasing as we go across the period, even though we're only occupying 2 energy levels? Well, nuclear charge is a positive charge, and electrons are a negative charge. And if you recall, oppositely charged particles are going to attract toward each other. So what's happening is as you go across a period, the number of protons is increasing, which is causing the attraction for electrons in the outer shell to be squeezed toward the center. So it makes sense that as the number of protons increases across a period, the size of the atom is going to be compressed a little bit slightly toward the center because the nuclear charge is increasing. Let's talk briefly about ionic radius. Remember, electrons are negatively charged. And if we take away electrons from any of the metals, it's going to reduce the energy level of those metals. So for example, lithium has 2 energy levels. We remove that 1 electron, it's only going to be occupying 1 energy level. So in general, cations tend to get smaller as electrons are drawn in closer by that positive nuclear charge. We remove an electron from lithium, the energy level occupied is only going to be 1 as opposed to 2. If we're talking about nonmetals or anions, chlorine has 7 electrons in its outer shell. So if we add 1 more electron, electrons are going to repel each other because they're negatively charged. Thus, adding more electrons to nonmetals is going to cause the size of the atom to get bigger. So in general, metals lose electrons and get smaller. Nonmetals tend to gain electrons and get bigger. You won't have table S to rely on this piece of information, so you're going to have to remember it. Ions of metals tend to get smaller as they lose electrons, and nonmetals gain electrons as they get bigger because the electrons are repelling each other. So let's try some problems using this information. Rubidium and iodine have different chemical and physical properties. Some of these properties are shown in the table below. Compare the atomic radius of the rubidium atom to the atomic radius of the iodine atom when both atoms are in the ground state. So looking up the values for atomic radius for iodine and rubidium should reveal that atomic radius of iodine is smaller than the atomic radius of rubidium. Another possible answer you could say is the rubidium atom is larger than the atomic iodine atom, or the rubidium's atomic radius, if you look it up, has a value of 215 picometers versus iodine, which only has 136. Any of these answers is correct. For problems involving comparison, make sure you identify which one is going to be larger and which one is going to be smaller. They frequently ask you about the size of atoms. It says, describe the general trend in atomic radius as each element in period 2 is considered in order from left to right. If you look at period 2, you find that the atomic radius decreases. And as the element, so you could just simply say the atomic radius gets smaller or the atomic radius goes down. As the elements of period 2 are considered from left to right, the atomic radius generally decreases. Please note that it's not asking you why it decreases, just simply to state that it does decrease. And remember, it's decreasing because the increasing nuclear charge across a period is also increasing. Protons are increasing and they squeeze the atom closer toward the center. Next problem. A magnesium atom that loses 2 electrons becomes a... This problem is slightly harder because it's asking you to recall what type of ion is formed when it comes to losing 2 electrons. Note that metals tend to become positive as they lose electrons because electrons are negatively charged. So you should be able to eliminate answer choices 2 and 4. It's going to become a positive ion. And recall that as electrons are lost to form a positive ion, the radius is going to decrease. So the answer choice is 1. That's the correct answer. Compared to a potassium atom, a potassium ion has... Okay, potassium is a metal. So as metals lose electrons, it's going to become a smaller radius. Answer choice 1 is correct. The radius of a lithium atom is 130 picometers, and the radius of a fluorine atom is 60 picometers. The radius of a lithium ion, lithium plus, is 59 picometers, and the radius of a fluoride ion, F minus, is 133 picometers. Compare the radius of a fluoride ion to the radius of a fluorine atom. For this problem, it's asking you to compare the ionic radius of fluoride to the neutral atomic radius of fluorine. If you look up the fluorine atom, you'll find that the fluorine atom is 60 picometers, and it already tells you that the fluoride atom is 133, so you can just merely state the values. You could also state that the radius of the fluoride ion will be larger than the radius of a neutral fluorine atom because it's inheriting electrons. You could have also said that the radius of fluoride is 73 picometers greater than the radius of fluoride atom. Here it's just taking the difference. Or you could just simply state that the neutral F atom is going to be smaller. Same problem. This time it's asking you to explain in terms of subatomic particles why the radius of a lithium atom is smaller than the radius of a lithium atom. Lithium ion is smaller than the radius of a lithium atom. So you must mention the subatomic particles in order to get full credit for this answer. Remember, the subatomic particles that contribute to atomic size have to do with protons and electrons. You could simply state that a lithium atom is losing its second shell electron. So the lithium ion is going to be smaller because it only occupies 1 shell of electrons. You could have also said that the lithium ion has 1 fewer electron, therefore it's going to be smaller. The lithium atom has 3 electrons versus the lithium ion only has 2, so this has 2 energy levels as opposed to 1. Or lithium ion has 1 less electron. Note that you had to mention the subatomic particle electron in order to get full credit. Okay, remember when it comes to atomic radius, you can always rely on table S to determine values when it comes to patterns. In general, atomic radius decreases across a period and increases down a group. When it comes to ions, metals tend to be smaller because they lose electrons, whereas nonmetals tend to gain electrons and become larger. Remember that trend, you'll be fine. Thank you for watching.